Good morning, students. In today's fluid mechanics and machinery class, we are going to study about the boundary layers. When a real fluid is passing through a solid boundary or a layer of fluid which comes in contact with the boundary surface or the solid surface, is observed that the real fluid velocity gradient exists only in a thin layer near the solid surface. This layer was named as boundary layer. Laminar and turbulent boundary layer. If the length of the plate is more than the distance, the thickness of the boundary layer will go on increasing in a downstream direction. Then the laminar boundary layer becomes unstable and motion of fluid within it is distributed and irregular, which leads to a transition from laminar to turbulent layer. In our previous classes, we could have studied about the Reynolds number, and so what is the Reynolds number for a laminar and turbulent flow and also a transition flow. So this short length over which the boundary layer flow changes from laminar to turbulent, we call them as transition zone or critical flow also. The boundary layer is turbulent and it continues to grow in thickness. This layer of boundary is called turbulent boundary layer. Definition of boundary layer thickness. The distance from the boundary of the solid body measured in the y direction to the point where the velocity of the fluid is approximately equal to 0.99 times the free stream velocity of the fluid. So we could have studied in the Newton's law of viscosity, the fluids are flowing with different velocity in a thin layer or in a streamline. So we could see from this diagram the velocity u is traveling with u1, u2, u3 up to u infinity. So through the pipe flow or a open channel. So displacement thickness is measured as a perpendicular to the boundary by which the free stream is displaced and account of formation of boundary layer and denoted by del H. The reduction in volume is given by displacement thickness. So integration of 0 to del rho into u infinity minus u into dy. So along the y direction. So displacement thickness del star is given by 0 to infinity 1 minus u by u infinity into dy. Momentum thickness. So from the diagram we could see, or if you take an example of our open channel, so when a stone is present in the flowing area, then the fluid, the velocity of the fluid will be reduced. So as a distance through which the total loss of momentum per second should be equal to if it were passing a stationary plane, and it is denoted by pi. Pi is equal to 0 to infinity u by u infinity into 1 minus u by u infinity into dy. So there will be, so if the velocity is reduced due to the stationary plate or stationary object present in an open channel or in a pipe flow, if some scalings are there, then the momentum and energy will be reduced. So that thickness is measured perpendicular to the boundary of the solid body by which the boundary should be replaced to compensate for the reduction in kinetic energy of the flowing fluid on account of boundary layer formation. So it is given by del E 0 to del u by u infinity into 1 minus u square by u infinity square into dy. So we'll see a problem on boundary layer. The velocity distribution in the boundary layer is given by u by capital U is equal to y by del, where U is the velocity at a distance y from the plate and U is equal to capital U, or the velocity is capital U at y is equal to del. Del being boundary layer thickness, find the displacement thickness, momentum thickness and energy thickness and the value of del star by theta. So we know the formula for displacement thickness. Del star is equal to 0 to del into 1 by U by capital U into dy. So then from the question, so U by capital U is given by y divided by del. So we directly substitute in the formula 0 to del into 1 minus y by del into dy. So when you integrate with respect to y, it becomes y minus y square by 2 del, 0 to del. So as we know, xn is equal, integration of xn is equal to x power n minus n plus 1 by n plus 1. Del star is equal to del minus, so we are substituting the lower limit and upper limit, and we could find del minus del square by 2 del is equal to del minus del by 2. So that is equal to del by 2. So it will be, so 1 del minus del plus del by 2 it will come. So minus del and plus del will get cancelled and it will be del by 2. Momentum thickness pi, it is given by 0, integration of 0 to del U by capital U into 1 minus U by capital U into dy. So they have given in the question U by capital U is equal to y by del. So substituting the values and integration, and we get, and substitute the upper limit and lower limit, and we get del by 6. Energy thickness, similarly SE is given by integration of 0 to del U by capital U into 1 minus U square by capital U square into dy. So from the question we know U by capital U is equal to y by del. So substituting the values of upper limit and lower limit, we get del by 4. And in the problem they have asked del star by pi. So boundary layer by momentum thickness. So del by 2 by del by 6. So that will get cancelled and it becomes 3. Thank you.